Hey everybody, this is 6.2. We're going to be talking about solving radicals. This first part, I just had people do that as a starter. Just a quick review of the things we've done before. The first part, we're just matching. One thing that you might notice for D, because this is a little different than what we talked about last time, but D is not in the correct form. So X should always be kind of by itself. And so what we can do to that, to take care of that, is we could factor out a negative. And then that just ends up, that negative ends up being, our B in that form, okay, for the radical form. So that's why that looks a little different. Just a couple other things that people maybe have questions on is like F, it's also not in the right form, so we can rearrange that. We could put the negative x in front and the plus 5 after, and then we can factor out that negative, and so it looks more like the radical form that we've been used to. Okay, so I just had people kind of have some practice with coming up with the domain and range just by using the equation. If you want to pause and give that a try on a few of those, that would be great. Okay, and then we did a quick review on simplifying radicals. So obviously that one's pretty simple. The square root of 25 is just 5. Okay, for B, when we multiply radicals, we can multiply them normal, like you would 2 times 2. Okay, so this would end up being the square root of 4, which ends up just giving us 2. Do that 2 very well. Okay, that becomes helpful when we have something like C. We can multiply the 2 and 7 to give us 14. And then when we multiply these together, again, the square root has to stay, but we would end up getting, not 4. We would get 16, and x times x is x squared. And we can actually simplify those pretty good. Like these individually, can't really simplify those very well, but after we multiply, it ends up just giving us 14 times 4 x. And then if we multiply those together, the 4 and 14 would give us 56x would be our answer. Okay, and then for D, very similar. The square root of 9 is 3, so 5 times 3 square root of x, or 15 square root of x. All right, and then just something really quick. You may or may run into this, but just in case, I just want to throw this in. If you need to multiply binomials, we know how to do that. It just looks a little different because we have square roots instead of maybe variables, but we end up doing the same stuff. We multiply and combine like terms. So if we multiply 1 times 2 is 2, 1 times negative square root of 5 is negative square root of 5. This will give us negative 2 square root of 5, and then this would give us a positive 5. So just kind of the same thing we talked about. Square root of 5 times the square root of 5 will just give us 5. Negative times a negative will give us a positive. Okay, and then we just combine like terms. So like terms, these are like terms, so that would give us 7. These are like terms, that would give us negative 3 square roots of 5. And there we go. I'll do one more. We can do our same box. This one actually will turn out a little nicer because they're opposites and some things might cancel out. So 4 and the square root of 3. So here we'll get 16, 4 square roots of 3, negative 4 square roots of 3, and this will give us a negative 3. Okay, and then if you notice that these are their opposites, they can cancel out, so our answer will just be 13. All right, I'll leave C for you if you want to give it a try. I have it filled in on the notes on Canvas. And let's go into solving. So there are a lot of examples here. As you notice, some of these are still filled in. These are the filled in note parts. You don't have time to watch and listen to all of these. So I have tried to pick some selected problems that I think will cover most of it. If you need to go back and look at these other examples, great. Okay, so our goal is to solve radical equations today. One thing we need to be aware of is that we can still have extraneous solutions. Extraneous solution here is a little different than we did with rational functions in our last unit. What can't work here is, well, first off, we can't end up having negatives in the square roots. So if we end up getting an answer and we plug it in, we could possibly end up having something that doesn't work out. It's possible that we could end up getting a solution that when we plug in, it doesn't make the equation true. And that's probably more like what you're going to see today, and I'll give you an example of that when we get to it. So let's go and do some solving radicals. Okay, so when we solve, again, it's the same solving that we've maybe done before, years past, is we're basically doing PEMDAS, but going backwards. So I'm going to kind of go up to this part and talk about it here. Okay, so our main idea is basically we want to get x by itself, because if we can get, not x, the square root, if we get square roots kind of by themselves, then we can square both sides. I think a better way to think of this is just doing PEMDAS backwards. That's what we do when we solve. We'll still add, subtract first, divide, multiply, and next is exponents. So exponents, whether you know it or not, a square root is actually an exponent. A square root is the same as an exponent of 1/2. And so that would be the next thing that we would want to do, is we'd want to get rid of that square root. And then P is our parentheses. We just want to do what's left. Okay, kind of go back to adding and subtracting and any dividing or multiplying. Okay, so hopefully that's helpful as we get going. So here's this first example. We already have the square root all by itself, so we kind of can't do any adding or subtracting or multiplying and dividing until we get rid of that exponent. So we will square both sides. That will cancel the square and the square root. So here we'll end up getting x plus 7 equals 9. Okay, and then we would just want to kind of go back to the beginning where we would add or subtract next. Okay, so we would just subtract 7, and we would end up getting x equals 2. So this would be our solution. Let me show you how we can figure out, or checking. We need to check whether we actually have a solution or not. Okay, so when that happens, all we need to do is, maybe I'll use a different color here. We'll use purple. So this is going to be our check. Okay, what we're going to do is we're going to just plug it in. So we have the square root of 2 plus 7 equals 3, and we're just going to simplify the left side. So that gives us the square root of 9 equals 3, and the square root of 9 is 3 equals 3. So check. X equals 2 is a solution of this radical function. Okay. Let's see if we can find one that doesn't work out. So let's try this example. Again, we're doing PEMDAS backwards. So the first thing would be adding and subtracting. We need to get rid of this positive 13, so we will subtract 13. We'll end up getting the square root of 5x equals negative 10. And then we would want to get rid of that square root by squaring. So just make sure that when we square something, it's important that we put parentheses like that with the numbers. Okay, so we'll end up getting 5x is equal to 100. And then we could divide both sides by 5. So x equals 20. Okay, so now again we want to check and make sure that that's actually a solution. So like when we end up squaring both sides, it kind of changes your equation. And we could end up having a quadratic that has two solutions, but this type of function might not have two solutions, right? When we graph these types of functions, oftentimes it will only cross one time. So if you kind of think about how x-intercepts are your solutions, you might end up having more solutions than there actually are. So we'll just plug those in. Again, we're going to keep everything. So this is going to be my check. Sorry, that's a 13. So 13 plus the square root of 5 times 20 is equal to 3. And we just want to simplify and make sure that that is actually valid. So 13 plus the square root of 100 equals 3. And then 13 plus 10 equals 3. And 23 equals 3. So is that true? Is 23 equal to 3? It is absolutely not. So x equals 20 is not a solution. It's an extraneous solution. Okay. All right. Here's another example. Again, we already have the square root term by itself, so we would want to go straight to squaring. So we end up getting 5x plus 6 is equal to x squared. So here's something that's a little different. Now we end up having a quadratic after we square both sides. If it's a quadratic, we need to have everything on one side. So we could subtract 5x, we could subtract 6, so we end up getting 0 equals x squared minus 5x minus 6. And then we solve it just like you did in our last unit. We would factor, so 0 equals, and we'd need to find the two things that multiply to negative 6 and can also add to negative 5. Okay, so that would probably come up to be x minus 6 and x plus 1. And then our solutions would have to be 6 and negative 1. Again, we're not sure if either of those are valid solutions. So we need to check by plugging those in, and we'll have to do it 2 separate times. So for our check, we would plug in 6. And again, you could use your calculator. You could put that into your calculator and you can check. I'll just be doing it by hand here. So this would be, oh boy, this would be 30 plus 6 is 36. And so we'd end up getting 6 equals to negative 6. So is that a valid solution? No. So 6 is an extraneous solution. Okay, and we'll try the other. So we would plug that in. So we'd plug negative 1 in, so square root of 5 times negative 1 plus 6 equals to negative 1. Simplify that. I think we'll get the square root of 1 equals negative or positive 1, and the square root of 1 is just 1. So that checks out, and that means that negative 1 is a solution. So we have one extraneous solution and we have one actual solution. All right, okay, so if you want to look at D, great. F, great. You can have a look at those. Let's look at E. So this one's a little different because we don't necessarily really want to have both of those on one side. So here is a special case where we could just square both sides and we'd end up getting 2x plus 7 is equal to 1 minus 4x. And then we'll just get x by itself. So we'd maybe want to add 4x and maybe subtract 7. And we'd end up getting 6x equals negative 6. And then we'd divide both sides by 6. So our possible solution would be negative 1. And again, we would want to plug it in to check. So to check, we would plug in negative 1 for every time we have an x. And then again, you're welcome to use your calculator to do the left side and then a calculator to do your right side. I think this ends up giving us the square root of 5 is equal to the square root of 5, which is perfect. Okay, so this is a solution. All right, so we're just going to do maybe 3 more examples and we'll call it good. Okay, again, these other examples on the right side, you're welcome to do those if you would like. All right, so again, we already have the square root by itself, so we could just go and square both sides. So 6x minus 5 is equal to x squared. It's a quadratic, which means we need to have everything on one side. And then and then we would factor. So what could multiply to 5 and add to negative 6? So I think negative 5 and negative 1. And then again, what would be our solutions? What would make this equation true? Well, x would have to be 5 or 1. And then we're just going to check by plugging that in. So square root of 6 times 5 minus 5 is equal to 5. And we just want to check and make sure that's true. So this will be the square root of 25. So check. That works. So that is one of our solutions. Wait, hang on one sec. Yeah, okay. I think I messed that up on the notes, so I'm going to have to fix that. And then we'll do it on this side. So the square root of 6. And we're going to plug 1 in. And here we'd end up getting the square root of 1, which is just 1. And check, that works out. So these both are solutions to that equation. All right. H, we already got that. I, okay, same sort of thing. We need to have the square root kind of by itself. So again, PEMDAS backwards would be adding, subtracting. So we'd want to add 2 and get it to that side. So now we can just square both sides. Don't forget that we'll need to put a parenthesis around that and distribute. So again, that's where we would maybe use a box. So x squared, 2x, 2x, and 4 combine like terms. So anyways, back to here, we have x plus 14 is equal to x squared plus 4x plus 4. Okay, because again, those will combine. Again, we have a quadratic, which means we have to have everything on one side. So we'll subtract an x, and we'll subtract 14. And we end up getting 0 equals x squared plus 3x minus 10. Factor it. So what multiplies to negative 10 and adds to 3? That would have to be like negative 2 and positive 5. So that means our possible solutions would be 2 and negative 5. And then we'll just, again, gotta check, make sure that works. So square root of 2 plus 14 minus 2 equals x, and x is 2. And we have to plug it into your original equation before you did anything else. So square root of 16 minus 2, which is 4 minus 2, which is 2. So check. That's one of our solutions. And then we'll do it again with the other. So this will be the square root of 9. Or, 3 minus 2, which is 1. Okay. And just double checking really quick, make sure I didn't make any mistakes. Wait, hang on one second. Does it look good? Yeah, so this would be extraneous. I'll have to double check. It makes me nervous. I have my filled in notes here, and it's not matching what I did before, so I'll have to go and double check that one, okay? Check that, Mr. Warner. All right, last example. Again, we need to have x by itself, so we'd want, or not x by itself, the square root by itself, so we'd want to add x to both sides. So we'll end up getting x minus 1. Get rid of the square root. Don't forget the parenthesis. And we'll want to distribute. Again, I'd encourage you to use a box. And then combine like terms. So x squared minus 2x plus 1. We'll just move this all to one side. And then factor. So what can multiply to 10 and add to 7? That'd be x minus 2 and x minus 5. And then we'll just need to check. So checking, we'll plug those in exactly with the original equation. So 5 times x, oh sorry, I forgot this part, x equals 2 and 5. So we'll plug in the 2. And then simplify. So 1 minus 2 is negative 1, and check. So that is one of our solutions, and then we'll do it again with the other. So this will be 25 minus 9, which is 16, and 4 minus 2, and that's 2 equals negative 1. And that is not a valid solution, an extraneous solution. Unless I made a mistake. I did make a mistake. Sorry, let me fix that real quick. So this should actually be a -5 because it's minus x. Sorry, my bad. So that ends up giving us an actual solution. So check. So both of those are solutions. So x equals 2 and 5 are solutions. All right, well, thank you for going through this. If you have any questions, let me know. And good luck.